Hi guys, in this presentation we shall learn why pointer size is same. Now before understanding the concept, I need to make sure that you should understand how exactly it works. Okay, now consider I have a memory location from 0 to 999. So 999 is a maximum memory location which I have taken. So inside of each memory location I can store 1 byte of data. Okay, 1 byte up to here 1 byte. So total there are 1000 bytes I can store in this memory. So how many address lines are required? So here is the question. So how many address lines are required to represent from 0 to 999 locations? So in order to answer that question, I need to make sure that you should understood what is the logic behind it. Okay, now if you consider 1 bit as an address line, then I can represent 0 and 1 memory locations. So if I take 1 bit as an address lines, then I can represent this many memory locations. If I take 2 bit, then I can represent 0 to 3. Okay, 0 to 3 I can represent. Okay, if I take 3 bit, then I can represent up to 7. Okay, so but we need the value 999. So how can we calculate it? So in order to calculate the value, we use simple math. Okay, for example, we need to have the memory locations, right? It's nothing but 2 power n should be equal to 999. Okay, so how to solve this? Apply log on both sides, then I'll get like log 2 power n should be equal to log 999. So how to solve this? You can see this is nothing but in this form. Okay, log a power m is nothing but m log a. So I can represent this as n log 2 equal to log 999. Okay, if I take this log 2 to here, then I can represent like an n equal to log 999 by log 2. So what is the answer for it? Okay, you can see that the value is 9.96. Okay, remember this value 9.96. 9.96 bits are required. Okay, so we know that we can represent 9 bit or 10 bit. We cannot represent 9.96. So there are two cases here. One is take 9 bits and another one is take 10 bits. So if I take 9 bits, then I can represent up to 512 memory locations. If I take 10 bits, I can represent 1024. Now our memory range is here 999. If I take 9 bit, okay, if I take 9 bit, somewhere here I'll get 512. So up to 512 it can be used. Okay, if beyond 512 9 bit cannot be used. If I take 10 bit, I'll get 1024, right? Somewhere here 1024 will be there. So inside is 999, so it can be used. So now my pointer size is 10 bit. Okay, so this is how we get. Okay, now usually in computers that we use in terms of bytes. Okay, so if I represent 10 bit in terms of byte, then I need 2 bytes. Okay, 8 bits in here, 2 bits in here, and remaining here 6 bits are zeros. Okay, now you should get the idea why pointer size is same, because we need to represent minimum value as well as maximum value. Okay, if I take 10 bit, in 10 bits if I say I want to access a 0th location, then I can place all zeros, then I can access this location. In 10 bit if I want to 999, then I can represent like this is the binary pattern. Okay, now you can see here only 10 bits are required to represent this as well as this. So if we know that if this can be represented and this can be represented, in between range also can be represented, that also in a unique way. Okay, now this is the core idea of that pointers. For example, if I take 64 kilobytes of data. Now what is 64 kilobytes? 64 into 1 kilobyte. So what is 1 kilobyte? You can see here 1 kilobyte is nothing but 1024 bytes. Okay, here 64 into 1024 is nothing but 65,536 bytes are there. Okay, now in order to represent this much of memory, so inside memory, okay, there are starting is 0 and last one is 65,535. Okay, so how many address lines are required so that I can access this memory location? 2 power n should be equal to 65,535. Apply log on both sides, then I'll get n equal to log of 65,536 by log 2. Okay, now if we calculate the value 16 bits, so here the address line we require is 16 bit, so the pointer size will be 2 bytes. Okay, first byte will be 8 bits and remaining will be 8 bits. Remember one thing, in the first case we got 2 byte, second case we also got 2 byte, but in first case we use only 10 bits. Okay, second case we use 16 bits, so that's why here maximum value is 1024, here the maximum value is 65,536. Okay, so that is the difference. Okay, the pointer size is same but inside the bits will be different. Okay, here 1 gigabyte is nothing but 1 kilobyte into 1 megabyte. 1 megabyte is nothing but 1 kilo into 1 kilo. So 1 gigabyte can be written as 1 kilo into 1 kilo into 1 kilo. So 1 kilo is nothing but 1024. So I can simply write 1024 into 1024 into 1024. Okay. If I need to calculate 4 gigabyte, then I simply write like 4 into 1024 into 1024 into 1024. Again, I need to find the value of the address lines. So I can simply write like n equal to log of 4 giga by log of 2. If you calculate the value, so if you calculate the value, we'll get the answer as 32 bits. Okay, 32. So we need 32 lines. So in order to represent 32 lines, if I take 4 byte pointer, so inside each one is 8, right? So 8 into 4 is 32 bits. So 32 bits are required to represent 4 gigabyte of memory. Okay, the pointer is the one which points the locations. Okay, so in order to access the locations, we need to know the size of the address line. So we need to know the size of the address line. We found some size. Okay, so that depends on the highest value. Okay, for example, if I say that I found the maximum bit required for representing 999, it can easily represent the below of 999. Okay, so that is the idea. Pointers are basically a memory address, so inside the pointers we store memory address, right? So this is the value statement. So the size of a pointer is determined by the maximum value of the memory you can address. So what this means is, for example, if I have a memory location like this 0 1 2 1 2 3 4 and 5. Okay, now I have an 6 byte of memory, 6 bytes of memory. Okay, so in order to represent this, if I take 1 bit, then I can access these two locations. Okay, these two locations. If I take 2 bits, then I can access 0 1 2 3. If I take 3 bits, then I can access 4 5 also. 6 and 7 also we can access, but here the memory is up to 5 bytes only. Okay, up to 0 to 5, which will be totally 6. Now here the value is 3. Okay, the point here is the pointer size is determined the maximum value. Here the maximum value is 5. In order to reach the maximum value, I need 3 bits. If 3 bits are required, then I can access from lower location to higher location. If I take 2, then I can't access this location. If I take only 1, I can access only this and this location. Okay, so that is the meaning of this, so that I can determine the bits, how many bits are required, so to the address line. So from that I can represent how many bytes are required to the pointer. So in this case I need a 1 byte. Okay, I need a 1 byte of pointer so that I can represent the addresses. Pointer size depends on the machine address lines. So what it means? Okay, For example, if I take 2 power 16, I'll get 65,536. So I can represent 0 to 65,535 locations. There are 16 address lines. So that is, this is represented. Okay. From, if I write 16 zeros from here to here, I represent this location. If I write 16 ones from here to here, I represent this location. Okay. In between, we can use any numbers. Okay. We have a unique value. So that is the meaning of machine address lines. Okay. I hope you understood why pointer size is same in a machine. Okay.